Okay, we're back with part 2 of the rope fraying tutorial here. So we've already talked about how to model this thing. Now we're going to get into the simulation of it a little bit here. So first thing I want to do, I just want to drop down a null and just type in rope. Make it black. Cool. And then just do a little cleanup here. This is the collider thing we created last time. Just going to put this in its own little box. Color that something so I can see it. Cool, so I've got my collider. Okay, so the first thing that I want to do is I want to put down a vellum weld. So what I want to be doing is I want to weld these points together. Remember, we split them in half up here and we created these groups called like R side and L side, and we're going to use those groups to attach them to each other. So let's put down vellum weld. Oh, why would it put it there? That doesn't make any sense at all. Okay, so put these here like that. Okay, and what we want to do, come on, it's loading or something. So basically up here you see these groups. We're going to put all the R sides up here and then all the L sides down here once this figures out what it's doing down here and lets me click on something. There we go. Okay, so we want points because our groups are point groups. Let me just hit cancel. Just get out of here. Points also. Maybe just put this to manual for a second so I can actually type something. Okay, and we have all these L sides and R sides and stuff. So I'm gonna go L side 1, L side 2, and then R side 1, and R side 2. So I basically just want these to, basically it's just gonna attach the L sides to the R sides, so it just welds them together in the middle. Okay. And then let's see, I want to probably output a group, just call it weld in case we need that. I think we can leave all these at default. The one thing though is we do want to make sure that we check this breaking box. So if we don't have the breaking box checked, it's going to weld these points together and it's going to be as if there was never a cut there, and this will just act like it's one solid piece. But we want these to tear apart, and so we're going to enable breaking. And we can just leave the threshold at default for right now because we're gonna break it using a weld attribute instead of the stretch stress. Okay, and then I think maybe just enable this. I'm not sure I can't remember what that does or not, but I think I had it enabled in my other one. Okay, so now we can put it back to auto update. Cool. Let that figure out what it's doing there for a second. I'll have a sip of coffee while I'm waiting for that. Okay. So we're going to be using mops to create a fall off that breaks this. Okay, so let's put this into a vellum solver first. Oh, actually, you know what? Silly me. I forgot to put down the type of constraints that these are going to be. We haven't told it it's going to be a rope. So what we want to do is use a vellum hair. That's probably why it was taking so long to calculate. So vellum hair. So we want these to basically act as if they're hairs. Now there's another one you can use that kind of creates string as well. I think it's just called vellum string. And in my tests, I couldn't quite get it to behave properly. It was giving me really weird results, and I found that using vellum hair actually worked a lot better. There might be a way to get it to work with the vellum string, but I couldn't quite figure it out. And so, yeah, I don't know. I liked this a lot better. Okay, so I ran into a little problem here when I was earlier when I was trying to get these nodes to work, and for whatever reason it was taking forever. The problem was I had this sweep node turned on, so all of my little curves here had a sweep around it, and that was totally messing up everything. And so make sure you turn that off. The sweep node was just for visualization. We don't actually need that. So we're gonna drop down a vellum hair like that. God, why did you put it there? I don't understand. Put it here. Okay, vellum hair, that's better. Now things are running smoothly. Okay, we want a vellum weld. Okay, great. And again, we want to just points, points, put all the L sides in one and all the R sides in the other. Okay, cool. So for our vellum configure hair, we want to change a few values here. So the first thing is we want to change this thickness scale. So if I click on this here, we can click visualize thickness and we can kind of see, maybe. Yeah, it's going to take a second. Well, there's a lot of strings, so maybe we don't need to visualize it. So basically, normally if you click on this, it shows you these little kind of circles up close that show you how thick it's going to be. But basically, this edge length scale controls how thick the strings are going to be. And I found for me, for what we've set up here, a value of 0.46 works. And that's just an arbitrary number that I made up based on this model here. And I just kind of played around until I got a number that worked. That's all it is. So, cool. The other things we want to change, I don't think we need to change much. We want this to be pretty stiff. So they shouldn't be super stretchy because rope isn't really stretchy. It's just like these really rigid fibers that are going to be turning. So I want tearing. I want this to be pretty stiff. So let's put something like that. See how that looks. 1 times E times 7. Let's do 1E 16. So I want this to be like super, super, super duper stiff. Okay, and then let's increase the damping ratio a little bit to 0.05. That'll just kind of help it not jitter a little bit. The bend stiffness, let's put this to all the way up here and 1000. Make it super, super rigid. Trying to make this as rigid as possible. Okay, cool. And then another thing I found when I was doing my experiments here, the vellum hair, even though I had put all of this stiffness into the stretch and the bend and everything, wait, why is this 0.9? I want 1000. Yeah, there we go. So even though I have all this stiffness here, it still wasn't enough for some reason, and I think it's because I'm using hair instead of the string, but I couldn't get the string to work very well. So though something that helped me out a lot is that I discovered this other node called the vellum shape match. So it's, let's see, vellum constraints. It's actually vellum constraints, but you change it up here to shape match. So basically this is vellum's, I think it's vellum's stiffest constraint. Basically what it's going to do is it's going to take whatever's incoming and try its very best to keep it that exact shape. So we're just going to put this after the hair, and we will, the shape match here, let's see, we want this to be cool, unchanged. We want the thickness to be calculate uniform. I think we want it to be the same as up above, cool. And then we want to put out a group, just in case we need it, we'll call it M stretch or something different, okay? And I think we can leave well, actually, I want this to be, I don't want it to be super, super duper stiff. So if we put it at the highest, it's basically not going to move at all. But I think this one, 1E plus 7 seemed to work pretty decently. Okay, cool. So let's just put this into a vellum solver and see what happens. So we have, basically we don't have any forces, we don't have anything working. It should just be gravity, basically. Let's just see what that does. Let's just turn it on just to make sure that gravity's working. Give it a sec. Okay, so it's moving downwards, great. That's what I want to see. So we haven't done anything yet, but it's falling, and that seems to, that's good. Okay, the next thing that we need to do is we need to, so first, actually, let's turn off gravity. So if we go to forces, make this 0. I don't want any gravity. So we need to attach these endpoints over here to our collider that we set up earlier. Okay, so that basically, if we don't do that, it's just going to fall, or we need something to be able to pull it apart. And to do that, we need a group on either side. So let's make those groups. So let's go group, and we'll call this end. Okay, and let's just make it a point group. And we'll use keep in bounding regions. And I'm gonna move it, hit enter on the keyboard so I can pull up this little graph thing. And I'm just gonna move it all the way over here. And I'm gonna get in really close. Let's hit spacebar 2 on the keyboard so I can see it from the top view. And I just want those edges. So let's just, those like first few points right there. Let's go like, there we go. Okay, cool. So that's great. And then we need another one on the other side with the exact same points. So let's just duplicate this, and we will, we'll call it end also, but basically the group name is being reflected here. And since you can't have 2 nodes named the exact same thing, we're gonna have to change this one up here just to be called end. And then we're gonna have it union with existing instead of replace existing. And all I need to do is take this and delete the minus sign, and it should group the other side. And now we have one group called end with both of these in it. Cool. Okay, so that's exactly what I want. So let's use a vellum attached to geometry. Attach to geometry. Put that here. And let it cook for a second. Okay, come on. Oops, crap, I need that. There. Okay, so what I want to do then is, let's move this over here for ease of use as our collider. So the collider should go in this 3rd slot of the vellum attached to geometry. Basically, whatever I put in that 3rd slot is what my vellum simulation is going to attach to. Okay, so right now, I don't have anything specified for it. So what's going to happen, it's going to try and attach everything, this whole rope, to that. Now I don't want that. I just want it to be the target group points. I just want it to be that end group there that I just made. So just give it a second to figure its shit out. I don't know why my Houdine's needing all this time to figure its shit out today. Maybe it's because I'm recording. Oh. Okay, so actually I was wrong. So up here, this is where you want to put your group. So change this to points, and we want this to be end. And then the target group is going to be primitives, and it's going to be this group here, call, that we set up earlier. So we want the target group to be call. So basically it's telling me to stick this thing, which is our collider, to the ends of these things, which is our rope, and that's what we want. Okay, so let's just simulate that really quick and just kind of see what happens. So I want to make sure everything's working. Right now I haven't, there's no forces really. I have it welded together. Braking is enabled. So with the distance threshold, where's my vellum hair, vellum weld, yep. Braking, got to enable that. So it should It might break depending on the pressure or the stretch threshold, but let's just hit play, see what happens. Give it a second. So while that's going, I'm going to talk a little bit. Basically what we're going to do is we're going to use mops, and we're going to create a fall off that starts on the outside of the rope and gradually works its way inward until the whole rope is encompassed in a one fall off. And we're going to use that as a way to define where the tear should happen, because I want the rope to fray from the outside in. That way it gives it that nice fraying look. And I don't want it to break all at once in one big piece. So we're going to do that with mops. It's really, really easy. Why don't we make a flip book, actually? Let's go 1 to 90. Okay, so I ran a few frames here just to make sure it's working. And you can see it is working. It's kind of giving us this funky behavior. It's kind of bunching, but we'll iron that out. So you can see that it is sticking to both of these little colliders that we set up. And the center part, even though it's giving this weird pinch effect here, it is welded together. So, cool. We have something going. That's what I wanted to see. Okay, so the next thing we're gonna do is we are going to set up our mops fall off. And so what I want to do is, before it goes into the vellum solver, I want to put down a mops shape fall off, and I want to put it right here. Kind of pull that off to the side, and I want to hit preview fall off. And what we want is a cylinder. Okay, so it gives me this cylinder shape. I can hit enter on the keyboard so I can manipulate that and turn it like this. And I want it to be, let's see, let's go, shit. Uniform scale. Let's turn the fall off to like that, right? right now, this is all 100%. Let's make this longer so that it encompasses the whole thing. Okay. And let's see, how do I want to do this? 0.2. Oops. Let's copy this, paste this here. Okay, so that I can just scroll one and there we go. That's what I want. Okay, so I want the fall off to be like this. So make the fall off 0, because otherwise there's going to be like a gradient, and I don't really need a gradient like that. I just want it to be like this. So we're going to animate it so that see where it's basically where it's blue. We're going to reverse this, but because where it's white is 1, where it's blue is 0, but we'll invert it in a sec. But right now where it's blue, I want the blue parts to start tearing, and then it's going to start tearing its way all the way to the center until the whole thing is torn. So we're going to start this at, let's say, 24 frames. So that gives it a second for this whole thing to settle and kind of start pulling. Okay, and then we'll put a keyframe here. Oops, like that. Keyframe. And then we will go over to frame 72 and keyframe this all the way to 0. Okay, cool. And then what we want to do is come into this remap part and hit fit, and we just want to invert this ramp. That way it starts at 0 and it goes to the white part is 1. Cool. Okay, so that's our fall off. And the benefit of doing a MOPS fall off here, because you can, if you have MOPS plus, you can put fall offs inside the solver and have it work dynamically. But the benefit of doing it on the outside here is that if you do it dynamically in there, the rope is going to be moving around a bunch, and the fall off, you have to like get it to try and match the movement of the rope. Whereas here, if you do it here on the static version, the rope's going to move around, but you're still going to it's like baked into the static version, if that makes sense. Okay, cool. So now that we have that, let's dive inside and let's set this up so that it can tear. So the first thing I want to do is put down a MOPS fetch attribute, and that is just going to pull in our MOPS fall off into the simulation. So it's already targeted to MOPS fall off. The inputs can stay the same, and that's it. So it just pulls in MOPS fall off. Great. Okay. And then the next thing we want a geometry wrangle. Geometry wrangle. Okay. Put this here, and we want to change the inputs to myself. Okay, and that's all we need to change. Okay, it's running over points. So we're going to use a little bit of Vex code. Don't be scared. I'm not a huge fan of code, but sometimes there's just stuff that you just kind of have to. This is super duper simple stuff though. So all we're going to do is we're going to use an if statement. Basically, I want to say if the MOPS fall off is greater than 1, then tear. Okay? So the way that works, you say if, and then you put a parentheses, and then you put your little statement in here, MOPS fall off is greater than, and I'm going to put 0.0001. So basically anything over this number, do something. So you put these little curly brackets here. So if this is true, then whatever you put in here is going to take effect. So I'm going to put I at weld equals -1. This is a little trick that I learned from the example files in the MOPS. When you download MOPS, it comes with a bunch of example files. It's super helpful. So I don't even know where you find I at weld, because if you look up here and you go to the vellum weld, like you'd think if you hover over this, the parameter is break threshold. You'd think that maybe you'd need to manipulate that, or something like, I don't know, but I think it's like a hidden attribute that you just kind of have to know about. Sometimes there's these weird ones in Houdini. I don't even know where you would find that. But basically what you're saying is you're just turning it off. You're just saying wherever MOPS fall off is greater than this number, there is no weld constraint anymore, and it just disappears. Okay, so let's run that and just see what happens. Okay, so I'm gonna pause it here while I make a little flipbook and we'll come. Okay, so I played around with it a little bit and here's what I got. I did change a few things in between while I paused the recording just to get this to work. So you can see it is tearing. It's doing what I want. It's working. The rope's behaving as rope. Cool. But now we just need to dial in the look of it because it's tearing very linearly and I want it to sort of like fray outwards radially. Okay, so the things I changed, number one, a little trick here is if you put down a connectivity node afterwards, it gives you this class attribute and then you can click on the little eye and hit class to visualize it. I like doing that for the rope because it kind of helps you see each individual strand. The other thing I changed, I made the animation time of this start earlier, so it starts now on frame 21 and goes to frame 39. Okay, and then in the vellum hair, I made the edge length scale back to its default, and the vellum shape match, I turned off the thickness. I just set unchanged, and that seems to help for now, so far. Okay, so that's cool. We got that working. The next thing we need to do is we need to figure out how to create a force that's going to make this sort of explode outwards as it disconnects. So what I want to do, I actually want to put down another MOPS shape fall off. Okay, and we're going to preview it again. And what I want this to be is, let's do spherical. Okay, let's put the inner radius. That's weird, why isn't it showing me? Let's try diving inside here. Sometimes the MOPS fall off doesn't show up like that. Let's change this to MOPS fall off 2. There we go. So cool. Sometimes you just need to visualize it like that. Sometimes it works a little funky. Okay, so let's put this all the way up to 1. Okay, and then I want this to be, let's scale it up in Y and Z and then down in X. So I just want this to be super thin. I want this to basically only have effect on the welded points. So right in the center. Okay, and I do want this to be MOPS fall off 2, by the way. We can just leave it like that. I don't want this to take over the original fall off. I'm creating a second fall off, to be clear. Okay, so why is this? Oh, I see, because I'm on the first one, right? Duh. Okay, so let's just get this to be something like that, or something like 0.001. Something like that, okay? So I just want it to basically be on the points that are connected, okay? And then what I want to do is I want to come in here, put down another MOPS fetch attribute, but this time we're going to be fetching MOPS fall off 2. Cool. All right. And then in our GeoWrangle, we are going to put down, we're going to create a new attribute. So this is a little trick I learned where and this is super, super handy. I use this all the time now that I learned it for a lot of different things, not just in Vellum, but you create an instance attribute or a integer attribute, and you can name it whatever you want. I like to call it time increment or time inc, and just set it to 0, okay? So basically what that's gonna do is we're gonna create a timer. Right now, every point has a timer of 0, right? Okay, now we're gonna create another if statement. So if at MOPS fall off is greater than 0.0001, and, so you put 2 and symbols, that means whatever, you have to put another thing here. So at MOPS fall off underscore 2 is greater than 0.0001, okay? I'll explain this here in a second. I'm just going to write it out, and then I'll explain it. I at time inc plus equals 1. Okay, so what does this mean? So right here, we set this attribute so that every point has an arbitrary attribute that we just made up called time increment, and it's the value of 0. But we created a second if statement. So if the mops fall off 1, the first one is greater than 0, and the second one we created is greater than 0. So that basically, I want these points here to be the only ones affected by this, and I want it to be triggered by the fall off that's going from outwards to in. Then if both of those things are true, then I at time inc plus equals 1. So when you put a plus equals, that means basically every frame I want it to increase in value. So as soon as this is true right here, for any of these points in the middle, it's going to start a timer counting up from 1 every frame. Okay, so and the way we can check this is we can put down like a pop group here. So pop group, okay, and I want this group to only. The reason I'm putting down this timer is because I want to be able to affect velocities here. I want to be able to basically at the moment these break for one frame, I want it to have an extreme outward velocity so that it pushes outwards, but I only want it to last for one frame. Okay, so that way when we have the timer, we can say, we can manipulate it that way. And this will make sense once you see it. I think I'm maybe explaining it kind of poorly here, but I think once you see it, it'll help. So we're gonna name this group broken, and let's enable the vex expressions here, and we'll go if at time inc equals 1. So basically, at the moment that these are broken, do something. And what I want it to do is put it in this group. So it's in this group. Okay, and then another thing we can do is we can go else if at time inc equals 3 in group equals 0. So it's only going to live in this group for like 2 frames between when the time inc is 1 and the time inc is 3. Okay, and we can check this. We can put down a pop color, and let's make this red. Okay, and I only want this to apply to the broken group. So basically you'll see these like little pops of red here in a sec. Let's just turn off the visualization of mops fall off. Let's come here. Actually, let's just look at it here. See if we can see it. Come in right up close so you can see. Something I'm going to do is I'm going to just put down a color. Oops. Put it right here. Just make everything white. It's going to override this color here. Let's turn off preview fall off there. Turn off. Oh, right. I need to click on this and turn off the preview there. There we go. So I put down this color up here to make everything white just temporarily so that it'll make it easier to see this red color when it does happen. Okay, and then I'm going to hit that and pause. Okay, so you can see it's all white, and then as soon as the statement is true for each of those things, the little tips turn red. So we can use that to manipulate something. So I want to add some velocity to these red parts so that they fly outwards. Okay, so what I want to do is I want to go up, and let's turn off this color here. Give me back my original colors. Okay. And I want to create a velocity volume. So I'm going to put down a sphere. We can template it here. And we can make this a lot smaller. And let's make the X radius like this. Let's make it like really thin. Like that seems right. Okay, cool. All right, and then let's put down an ISO offset to turn it into a volume. Maybe if we make the background dark, we can actually see it. Cool, let's put down like 100 divisions to make it thinner. Okay, and then let's scatter some points. Turn off relax iterations, put down like a bunch. Okay, and then what we want to do is put down a wrangle, and we'll put at n equals at p. Okay, so what this does is it adds normals to basically pushing outwards. So it's using the position of each point, so from 0 to wherever the point is, to create a normal. So all of these are sort of pointing away from the center, which is exactly what I want. Now I want these to be normalized though. These are going to be all different lengths. So the ones that are closer to the center are going to have like a really short length. The ones farther away are going to have a longer length. So I can just hit normalize, or type that, and put another parenthesis here. And that normalizes them. So they're all now the same length. They're all a 0 to 1. Okay, and then the next thing I want to do is I want to put down an attribute adjust vector. Attrib, if I could type attrib adjust vector. Come on, you fucker. There you are. Okay, and the attribute I want to adjust is n. And I want to add some noise. Okay, and I want this to be 0 centered so that it goes from negative, it goes all over, and just a little bit of noise, 0.01, and I want the element size to be much smaller. Like, let's put the amplitude up a bit just so we can see what we're doing here. There we go. So really just kind of noise it up a little bit so it's not all going out at the same rate. So we'll just do 0.0003, something like that. Okay, and 0.01. Okay, cool. That seems to be decent. Okay, and then what we want to do is hit volume raster. We can turn this off. Hit volume rasterize attributes. Volume rasterize attributes. So we have our normal on there, but we need to turn this into a volume in order for the solver to be able to read this. Okay, so the attribute we want to rasterize is n. Okay, and that's pretty much it. Okay, so now if we middle mouse, we have a volume called n. Okay, so then what we want to do is we want to go into our solver and we want to put down a pop advect by volumes. Okay, and actually let's go up, let's put down a null, call it vel, make it black, copy that, and we'll come in here and we'll go paste. Okay, and the field name is n. So as long as it matches, it's fine. That'll be the volume. Okay, and we want, oops, just check something here. We want the velocity scale. We want to increase it a lot. I'm going to put like 350, and update force is fine. And let's just see what that does. Let's make another little flipbook here and see how that works. Something I forgot is in this pop advect by volumes, we want to make sure that we enable the group and make sure that it only applies to the broken group that we created. Otherwise, it's going to just, the whole thing's going to go crazy. So make sure it's broken, the broken group, and then let's do that. Let's do a flipbook. Okay, so I did a few tests here while I paused the recording, and I got it to work here. I realized I had made a mistake in some of my settings here. Something was going wrong, but I think I got it working here finally. I can kind of show you the result. So basically, you're going to need some lead time here for this to kind of relax, and then it's all about kind of how you time it, really. So let me pause this and kind of show you what I did. So the first mistake I made was with this vellum shape match here. I accidentally had this at 1E plus 7. I wanted it at 1E minus 7. Now you might need to, depending on how tightly wound your strands are, what direction they're going, how many of them there are, you may need to adjust your settings a little bit. I found 1E minus 7 worked pretty good. I also changed the mass on both the vellum hair and the vellum shape match to calculate varying and 0.001. And I changed the edge length scale to 0.46 on both of these. That's pretty much it. Okay, and then the other thing I did was, if you come to the little collider thing, I guess I left that mostly the same, just kind of slowly going. But the trick to getting this to work is getting the timing of when the rope gets taut, like pulled completely taut, with the timing of this. So I adjusted this to happen a little bit later. So now, if you take look at the preview, it starts at frame 81 and ends at frame 158. So basically, depending on your simulation, depending on how stiff your constraints are, how far your colliders are kind of pulling on either end, you may need to adjust the timing of this to get it right. It took a few tries, but this is kind of just what worked for me. So I've got it cached out now, right here. Cool. And we just come to a nice frame. So it's working. It's fraying outwards. It's being pulled apart. And we're only going to see this part. You don't need to see all these little pinched parts here. We're going to be zoomed in or wherever. So let's see. Let's enable class. Cool. So what we can do, and actually something that I realized, I have class enabled on. It looks like it's working on the parts in the middle, but on the outside it's all one piece, and I wonder why that is. So if I come to the outer, visualize class here. Oh, maybe I don't have class. Ah, that's why. So on these other two, on the inner one back up here, I put a connectivity, and then on the middle ones, I've got connectivities on all of these as well. But I guess I forgot to do it on this. So let me put down connectivity. That's okay. We can just attribute copy it. Let's do it. We have to do it before the clip. There we go. Okay. And then what we'll do is we will take this, go attrib copy, and the attribute we want to copy is class. And we'll do it to, go like this, Shift R to reverse it. There we go. Okay. So the reason I want to, you can put a connectivity node down here if you wanted, but what it's going to do is, let me just show you. Let me show you why you shouldn't do that. So if I put one here and visualize class, do you see, well, I don't know if you can kind of see it, but oftentimes there's like this little split right here. It'll show up. I guess you can kind of see that there's like a harsh line right there. You see these? So we're going to be using this to color and shade everything. So we don't want this harsh line where the points are divided. We want, see the difference here? So you can see this one, and then the one that we copied. See, it looks like all one big piece. That's what we want. Okay, cool. So we've got that. So great. Okay, so now we've got our simulation. Now what do we do? Well, now we're going to add some hairs to it, and then we'll go on to lighting and shading it. Okay, so first thing we want to do is we want to drop down a color node. Oops. Put this here. And we want the color node to be random from attribute. And we get let's turn off class. We want it to be not random from attribute, random from attribute, and the attribute is class. Okay, so that way we can use, because you can't, it's hard to use class in a shader. For some reason I couldn't, so this way now we have this class information basically stored as color. Okay, the other thing we want to do is we want to separate the left side from the right side. So let's go to the point where it's basically broken. So what we need to do, we need to separate the left side from the right side. So something I forgot to do before we cache this out is basically group each side separately. That's something we're going to need to do for the to scatter some hairs on it. So it's okay. We can fix that without having to recache if you don't want to. So we can just come back up here and we'll just go group, and I will just do points. It should just be all of them, and we're just going to call this right. Oops. Right, and this one will be left. Okay, and we're going to copy both these, and we'll do the same over here. So we'll just do, oops, do right and left, and we can just change this to be right and this one to be left. That way they have the same name. So even though they say right one and left one here, the group name is right and left, just like the first one. Okay, and then we'll do the same here. So we got right and left. Okay, so we should, let's come down here, make sure that we have them all. So if we hit blast, let's just check to make sure that we have these correctly. If we blast right, great. So we've got that, or delete non-selected, we have left, great. Okay, cool. So what we can do is over down here, we can also do a group copy, and we'll do the same exact thing. This to take this guy from here, group copy, and the group we want to copy, we should have right. Yep, we've got right, and we've got left. Okay, cool. So what we can do is we can split this based on right. So we've got right, put down a null here, and a null here. So we've got this side and this side. Excellent. Okay, so then what we want to do is we want to scatter points all over these little hairs, all over these. So let's do, on this side, let's do a scatter. Oops. Scatter, cool. And let's do relax iterations, turn that off. Let's put like a lot. Let's put like 700,000. 700,000. A shitload of them. Okay, cool. And then the other thing we want to do is we want to output attributes. We want to put down a prim source prim and prim UVW attribute. So that's going to help us stick these points to to the thing. So we'll do, let's see. So we have all these points. Now I don't necessarily need these hairs to be because we're going to, each of these points is going to end up being a hair. I don't need the hairs to be on the inside. That's just a lot of points on there. I really just need them to be on the outside. So let's come back to the first frame right here. And then we're going to delete the core, the parts that are in the middle. So we're going to go delete like this. And let's put down a time shift and have it on frame 1, so it's stuck there, okay? So then we want to delete node. Actually, we want to group first. We're going to group these ones, and we'll call this del. We want to put down a tube like this, put it on the x-axis, make the radius scale a lot smaller, make the height something like that, put some end caps on it. So let's do like something like this, okay? And then let's make it a volume, so VDB from polygons. And it should be, I think it should be a fog VDB, 0.05, let's go 0.005, something like that. Okay, and then let's plug this into the second input of the delete group. Okay, let's change this to points, and then keep in bounding regions. We'll use keep in bounding regions here, and we want bounding volume. So, okay, oh, we want a little bit of isosurface, there we go. Just like 0.01, okay? Cool, so we want to invert that so that it only selects the middle, and then that's our group, delete, and then we'll use down here on the delete node, points, and we'll use, the group is del. Okay, so now we should have a hole straight through the center. So we're only scattering points. So we went from having 700,000 points to 452,000 points. Okay, cool. So then what we can do is put down an attribute interpolate. And what we want is the first input should be this guy here. And, or sorry, the first input should be this, and the source should be this. So let's check if this is working. These points shouldn't change. They shouldn't jitter, basically. So let's watch here. Yeah, so if you check out right here, you can see these points attached to the strand. They are moving with the strands without jittering every frame. That's what we want. So cool. Because otherwise, if they're jittering, then all the hairs are going to jitter, and we don't want that. Okay, cool. So we've got that. Let's do the exact same thing for the other side. So if we just copy and paste these right here, actually, we can just undo that. We can copy and paste these guys here. And then we want to replace this one. So now we've got the other side. Great, okay, cool. So we can now, let's kind of move this off to the side, clean it up a bit, and then we've got this guy in the middle that we're sharing. Okay, cool, so we've got the left side and the right side. So now let's put down an attribute delete. Delete. And what we want to delete, just kind of clean this up, all except for normal. And then the primitive attributes, all except for class, and vertex attributes, everything, or sorry, detail attributes, everything. So we now have, it's cleaned. Okay, cool. We'll do the same on the, we'll copy and paste this on the other side in a second. Okay, now let's put down an attribute adjust float. Attrib p-scale is what we want to adjust, and we want it to, operation is set initial, and we're going to go random, And the min and max is going to be 0.002 and 0.18. And then we're going to kind of adjust this here. We can just bring this guy down something like to, oops, let's open this up so we can see what we're doing. Position 0.97 and the value is 0.2. So that way we have like, we shouldn't have any hairs that are, we have some hairs that are 0. Maybe we'll do like a 0.0001, something like that, or 0.001, 0.01. And then we have like some small hairs, lots of small hairs, and then we have a few big ones at the top. Okay, and then we're gonna put down an attribute randomize. And the attribute we're going to randomize is orient, which is a 4-dimensional attribute. Let's see, we also want to, the inside, we'll do inside sphere, and let's do cone angle. And the cone angle, let's just put 160. All right, these are just values I found worked pretty well. Okay, the last thing, now we need to make a little hair and copy it to the points. So let's put down a line, so we can see that. Okay, and the primitive type, we can put NURBS. Sure. The length, let's bring this down to 0.1. So it's really small. Let's give it 3 points. So we have like that. I don't know if you can see the points very well. Okay, and then we'll just do an edit. Just do like, just grab like, hit S on the keyboard, make sure we're on points, grab these two, and then hit Enter or T, and we can just kind of move them out like that. And let's grab, or maybe let's grab this one here and hit T on the keyboard and move it back this way. So now we have we have this sort of curly hair. Great. Okay. Nice. And we want this to be, let's just transform it so that it is in the Z plus direction. Like this. Come on. Why are you not working? Okay, let's hit match size. Let's go justify Y minimum. Okay. There we go. Okay, so we want this facing the Z in the Z plus direction. Okay, so now we have our little hair. Okay, and we're going to copy it to points. Copy to points. So we got that geometry to copy. Make sure you can turn on pack an instance. Yeah, let's do that because there's like a shitload of hairs. And let's turn off this. So now we see that we have lots and lots of hairs. Okay, so we're going to do the exact same thing for the other side here. So just copy this stuff. And the reason that we're doing this on both sides separately instead of all at once, because if we copy it all into one tube, when it pulls apart and finally separates, these little hairs get confused as to which side it should be on, and it kind of messes up. So it's a lot easier if you just do them this way. So now we'll just put a null, and we'll say hairs 01 and hairs 02. Okay, great. So we've got that. Let's pick a frame so that we can kind of light this, and I can show you what we're going to do. So right here, I'm just going to come up to this guy here. This is going to be our render thing here. Let me just pick like a part where it's like starting to fray. So something like that. Okay, and then let me just Command C or Control C, copy this guy, and we'll go up, put down another geo. We'll call this hairs. And we'll do object merge that in. Now we got our hairs. Let's duplicate this and then just change this 1 to a 2. Now we've got the other side. and then we can merge them. Cool. Okay, so now we have our hairs and our rope. And for the hairs, we want to go redshift object, go to strands, and the render object as strands. So that's what's going to make a huge difference. We don't want to actually render this as geometry. Rendering it as strands, as a strip, works really, really well. And I found that I needed to adjust this down to like 0.08, but you can kind of you can play around with it to get what you want. So let's put a camera down. Let's look through it, and let's back the hell up like that. So maybe let's like rotate it, something like that. Cool. Okay, and then let's just put down an RS dome light, or let's put a sunlight for now because it's just easy. Okay, and then let's fire up the render viewer and see what we get. Excuse me. So making this, once you get it set up, get the whole setup going, it's a little tricky at first, but once you get the setup going, you might need to tweak your numbers a little bit, run the simulation a few times, depending on what type of rope you made. The numbers I'm giving you here are just ones that I felt like worked pretty well for my simulation, but you can try adjusting how fast the rope pulls apart by re-keyframing the little colliders. You could keyframe the mops fall off so that it does it all at once or does it a lot slower. You could add more strands. You could also increase the stiffness in the shape match. Okay, so immediately I noticed this looks like hot garbage. And why is that? Why am I I'm seeing these little strips? That's super weird. I'm not seeing the strands of my rope. And that is because I forgot to hit the rope as render as strands as well. So let's just turn this off so that I don't crash it. Sometimes that's what happens. So let's come here. Let's go to redshift object, strands, render as strands. I want this to be a cylinder with 4, and then my default scale should be 0.0005 and 0.7. These are numbers I found that I think just worked for me pretty well. The hairs are obviously way too big, so those ones I'm going to need to adjust that. I think it's because 0.05. I think that's what it was. I forgot to do the default scale like that. So let's try it again. So let's fire this up, see what it looks like. So the benefit of doing it this way with redshift rendering as strands is it renders much, much, much faster than if you were to actually sweep each one of these with geo. It calculates it a lot faster. It's like not even real geometry, which is super nice. But it's going really slow right now. Let's see what this looks like. There we go. Okay, so we've got our rope. You may need to adjust the thickness. Let me just adjust my light here so I can get some more contrast or something, or some, yeah. Cool, okay. So I think I may need to make my strands a little thicker and my hairs a little thicker as well. So it's just kind of about finding the right numbers to see what works. And actually, let me put down an RS light. Let me turn off this sunlight. And I'm going to move this here for a second because I want this to be backlit so that I can see, I want to see the little hairs. So let's move this here like that. There. So now you can kind of see the thickness of the hairs. That's really going to help bring that out. And let's turn the power of this light down to like 10. Okay, and let's grab another one and spin it this way. And we can put it maybe like behind. So we have like a rim light both on the bottom and on the top. That'll help it look kind of cool. There we go. So that helps us see it a lot better. So we've got this rope, we've got these fuzzy little strands. So I think the strands actually, or the hairs actually are at the right scale. I think that's pretty good. But I think that my rope, I think that these should be a little thicker. So let's do 0.9. Let's see what that does. And if that doesn't crash my thing. So let's watch this. Yeah, it's a little better. Let's go 1.2. Better, I think. Cool. So we've got these little fuzzy things on there. We've got the rope. Okay, now let's texture it in Redshift. So we have this, right now it's just white. It's gonna look a lot better if we put a texture on it. So for the rope, let's go to the render tab, type /matte/rope, which does not exist yet, but we'll create that. So hit that little arrow, it takes you to the material context. Here's a little trick, by the way. I always do this in my projects. If you're in the material context, you can hit Control and then push a number. I like to push 2. That sets a quick mark. And if you go to the object, you can hit Control 1 and that sets a quick mark. So then I can just hit 2 or 1 or 2 or 1. And then I can also go to the out context and I like to do Control 3. So 1 or 2, 1, 2, 3. You can jump between contexts really quickly. You can use as many numbers as you want, and you can change them anytime you want. So that's really, really handy to go to for a quick workflow. So RS Material Builder is what we want. Okay, we'll call this rope. And the main thing we need is a RS point attribute. Remember, we set that class attribute to be color. So each individual strand can be colored differently. So let's plug this directly into the base color and then fire this up again and see what that does. It should be all multicolored like we saw in our wireframe view a little bit earlier. Come on. There we go. Yep, there we go. Okay, so now let's adjust the reflection roughness. It shouldn't be reflective at all because a rope is like totally dry. And then let's put down a ramp and put this in between there so it turns it to grayscale, and then push this little tab and hit sand. And that'll give you a good start, but that's still, I think, a little too saturated. Let's kind of make this lighter, something like that. Maybe a little darker actually on that side. And then this one, I think it's too yellow. Let's make it more like a little more towards orange, like that. Maybe a little more desaturated, something like that. Okay. And then let's go back to our lighting here. Let's maybe increase the power of these to like 20. Okay, and then our camera, I like to go color correction, or sorry, optical, and change it to filmic. That gives me a little more control over the exposure. There we go. That's looking better. That's looking a lot more like a rope. The other thing you can do is, if you wanted this to be multicolored, let's just duplicate this so we don't lose that. You could change it to, Viridis or whatever you wanted to. So that way you can kind of make one of those like multicolored like rock climbing ropes or something. I think I have some of those in the example that I made. And you can adjust the position of these knots to get different looks on the strands. But let's keep it just a classic rope for now. So that's cool. The other thing I found I think helps is put down a frenet, or put some sheen on it. So let's see if that does anything. So let's just take a picture of that. Let's turn the sheen off. I think it helps a little bit. So this is with it off. Zoom in close. This is with it on. I think it makes it help it feel a little bit more like a rope. So let's put the sheen back up. Maybe just a little bit. Something like that. Cool. So that is basically it. At this point, you can retime it. You can add more strands. You can play with the stiffness of the simulation. You can change the size of the fibers. Let's move this farther out and see what that does. See how that looks. But now you have this asset. It's dynamically tearing, it's fraying, looks pretty cool. So there you have it. I will see if I can clean up my files here and figure out how to leave these files for you guys to dig through if you want. But yeah, that's pretty much it. I hope that this really helps. I didn't find much information about this, so I'm sure there's probably a way better way to do this. Just like in Houdini, there's like a billion ways to do everything. But I'm just showing you how I did it for my project, and it seems to work pretty well. Kind of took some experimenting and fiddling to get it to this point. But yeah, I think it looks pretty good, and let me know what you think. Thanks.